Hi students, welcome to SP tutorial MBL. So in the last class we have been started with haloalkanes and haloarenes. So in the last class we have seen the introduction part and also the classification of haloalkanes. Today we'll see the nomenclature of haloalkanes. So in the nomenclature of haloalkanes, so usually all organic compounds or chemical compounds will have two types of names. The one is common system nomenclature or common names, whatever we call in common, and another one is the IUPAC rules, IUPAC nomenclature, which follows the IUPAC rules. So in the case of common names for haloalkanes, common names, or it is also called as trivial names. Trivial names. So if you consider the common names of these haloalkanes, see the all haloalkanes will be written as alkyl halides. Alkyl halides. These are the halogen derivatives of alkanes. So then they are derived as the the alkyl name followed by the halogen names. And if you have any dihalides, for example, if you have geminal dihalides, in the case of geminal dihalides, we will write them as alkylidine halides, the common system, alkylidine halides. And if you have a vicinal dihalides, vicinal dihalides will be named as alkylene dihalide. Alkylene dihalide. Okay, this is how we actually names will be given to the haloalkanes in the common system. When it comes to the IUPAC nomenclature, you all know IUPAC is the International Union of Pure and Applied Chemistry, which has given a set of rules for naming any compound in chemistry. So when it comes to the IUPAC names, it follows all the rules of the IUPAC, and here haloalkanes will be written as haloalkanes, and haloalkanes will be like haloalkanes, and haloarenes will be haloarenes. And if you have any substituents, they will be written in the prefix with the respective position numbers. So this is how we will actually having the nomenclature of haloalkanes and haloarenes. So we'll see some examples, then we'll come to know what it is all. Okay, so we'll write both the names first here. Examples. So here I'm going to write the structural formula as for structures. Here the common name, and here IUPAC names. IUPAC names. The first nomenclature, that is CH3 Cl, the first member of the haloalkanes, the chlorine members. So it is derived from methyl, like alkyl halide. It will be written as methyl chloride. Methyl chloride. And the IUPAC name will be like haloalkanes. Then it is a chloromethane. Chloromethane. Okay. In the same way, CH3, CH2, Br. Common name will be ethyl bromide, and IUPAC name will be bromoethane. Bromoethane. When it comes to three member, that is CH3, CH2, CH2, Cl. It is N-propyl alcohol, N-propyl, sorry, chloride, neopropyl chloride. Okay, the IUPAC name will be, it is at the first position, the halide substituent, the chloride substituent, so it will be written as chloropropane. Chloropropane. One of its structural isomer, that is the position isomer, CH3Cl. The common name of this compound is isopropyl chloride. Isopropyl chloride. Its IUPAC name will be, the chlorine as at the second position, that is it. That's why it is 2-chloropropane. 2-chloropropane. So you can also name it as 1-chloropropane. This one is 2-chloropropane. Those are both are isomers. When it comes to the four-membered, for example, butyl derivatives. Okay, there is neo butyl or N-butyl bromide. So here numbering 1, 2, 3, 4. It is the bromide substituent at the first carbon. So it is 1 bromo or just bromo butane. Bromo butane. And when it comes to the, it's one of other isomer, that is CH3, CHBr, CH2, CH3. This one is secondary butyl bromide. So here the bromo derivative or the bromo substituent at the second carbon, 1, 2, 3, 4, it will be 2 bromo butane. 2 bromo butane. We have also tertiary also. This is one is primary neo butyl bromide. The secondary butyl bromide is secondary, and we have also tertiary butyl bromide, CH3, 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 Br only. I'll write. Okay. This is the tertiary butyl bromide. Tertiary butyl bromide. If you write its IUPAC name, the longest continuous chain has only 3 carbons. So if you consider 1, 2, 3, this also will become a side chain. This methyl group will be the side chain, and we also at a bromo, which one? Bromo substituent. So here it is 2 methyl 2 bromo propane. It is 2 methyl 2 bromo propane. In the case of butane, butyl derivative of the haloalkanes, we have all three: primary, secondary, and also tertiary alkyl halides. Okay, if you see another examples like this one. This one is the vinyl chloride. Common name is vinyl chloride. IUPAC name is, at the first carbon we have chloro. It is ethene. So IUPAC name will be chloroethene. The same way vinyl chloride. Allyl chloride, if you see, CH3, CH2, double bond, CH, CH2, Cl. This one is allyl chloride. When it comes to the IUPAC name, position 1, 2, 3. Okay, so as it is substituent, it can get the lesser number because this double bond is more, gets the higher priority than the chlorine. So here it is 3 chloropropene, 3 chloro, 1 propene, or prop 1 in or propene, all same. 3 chloropropene. Next examples for these geminal and vicinals. Yeah. CH3, CH, Cl, Cl. So it is one of the geminal. It is one of the geminal. So geminal will be like alkylidin halide. Alkylidin halide. Here we have 2 carbons, means it will be ethylidin chloride. And the IUPAC name will be 1, 2. So at first carbon we have 2 chloro. So that is why it is 1, 1 dichloroethane. So this is the example of geminal dihalides, alkylidin halide. So when it comes to the vicinal, for example, Cl, CH2, CH2, Cl. It is a vicinal. Adjacent carbon has the 2 chlorides or halogens. It will be like alkylene dihalide. So it will be ethylene अथवा ethylene ethylene chloride, sorry, dichloride, ethylene dichloride. Here if you write the position 1 and 2, so 1, 2 dichloroethane, 1, 2 dichloroethane. Yeah. We also had a benzylic halides. So there if you see an example, benzyl chloride, common name is benzyl chloride. It is an example of benzylic chloride. So if you come to its IUPAC name, it will be 1 chloro or chloromethyl benzene. Chloromethyl benzene. So chloromethyl benzene. So this is how this all have been given the names according to the common names and also the IUPAC names. These names are very important, so you please go through all the names. Nature of the carbon halogen bonds. So in haloalkanes we usually found the carbon halogen bonds, and this bond is a covalent bond. So here, though it is a covalent strong bond, but due to the halogen atom is an highly electronegative elements or atoms, so it pulls the electron towards it. So here then this halogen gets the partial negative charge, this carbon gets the partial positive charge. So that's why this carbon halogen bond is polarized bond. It is a polarized bond. Okay, it is not a neutral bond, it is a polarized bond. There is a creation of the partial negative charge over the halogen atom and the positive charge on the carbon atom. And if you see, there are 4 halogen atoms, so fluorine, chlorine, bromine, iodine. There also this bond length and bond strength will be varying. So let us see. If you see the size of these halogen atoms, you all know it is increases size of the halogen atom increases from fluorine to iodine. As we all know, the atomic size increases down the group, and as the bond, sorry, as the size increases, halogen size increases, the bond length also increases. Bond length also increases. Bond length also increases from carbon fluoride bond to carbon iodide bond. Okay, as bond length increases, the effective nuclear charge will be decreasing, hence the bond strength will be or you can also call enthalpy. Bond enthalpy also increases as the bond strength increases. Both are same. Bond strength is nothing but the bond enthalpy. If it has higher bond enthalpy, bond strength is also more. So bond strength, bond length and bond strength are inversely proportional. As bond length has been increased, bond strength will decrease. Bond strength will decreases from carbon fluoride to carbon iodide. If bond strength is decreasing, then it will be highly reactive. So the reactivity will increase. If you see the reactivity increases from CF2, that is carbon fluoride bond, to the carbon iodide bond. If you write this bond length and bond strength and also the reactivity is inversely proportional to the strength. Okay, so we will see that is the order of bond length. If you see this bond length, so if you see the bond length, the carbon fluoride bond's length is lesser than the carbon chloride bond, then the carbon bromide bond, and the carbon iodide bond is the higher bond length, because carbon iodine has the biggest size than the fluorine bromide iodine. So this order will be followed, and it comes to the bond strength. So it is the order of bond strength. Order of bond strength. If you see the order of bond strength, so here if you see this RF, bond strength decreases, means RF has the higher bond strength. As small size, more strength. So RF has the higher bond strength and RCl has the lesser one, RB here has the lesser one, and RI is the least one. Okay, and automatically the order of reactivity, if you see order of reactivity, so as it has a low strength Ri and high bond length, so the alkyl iodides are more reactive. Alkyl iodides are more reactive than alkyl bromides, than alkyl chlorides and alkyl fluorides. So the size increases, length increases. Length increases, strength decreases. Strength decreases, reactivity increases. These are the things, basic things we should know, and this is how these bonds are present in the carbon halogen bond. So the carbon halogen bond is especially depends upon the nature of halogen. Nature of halogen. All the halogen atoms are electronegative, hence this bond becomes polarized, and the variation you can see from fluoride to iodides based on their this size, strength, length, and also reactivity. Okay, this is about the nature of carbon halogen bond. Thank you for watching. Please share with all your friends and like my all videos, and do watch all my videos. In the last session I have discussed the first session of haloalkanes and haloarenes. where I have discussed the introduction part and also the classification of haloalkanes. The classification of haloalkanes is very much important. Please go through that video completely, and also thoroughly please watch this video fully, and please subscribe to my channel. Thank you.